Okay, we're going to learn how to graph a line from an equation, and it'll help us understand this equation a little bit more. So this is a linear equation. It comes in the form of y equals mx plus b. We don't see an m here, so notice when a variable has no coefficient in front of it, we just assume that that's 1x. Right? So you probably remember that this is the slope, and if its slope is 1, I'll just write it in here, slope is 1, then we know that we have a change in y over a change in x that equals 1. So what we can do is just pick any point on this line that we know. And right now you might feel like we don't know any lines here, or know any points here, but we do, right? So we remember slope, but the other important thing to remember is b, right? B is our y-intercept. That tells us when x is 0, right? When we haven't started multiplying yet, when x is 0, then y will be 5. Again, that y-intercept, if we look at the graph, that tells us that this point right here, when x is 0 and y is 5, that's where our line is going to cross, the y-axis. Now, it could cross anywhere. It couldn't cross anywhere, I take that back. What I mean to say is that it could have any slope at this point. It could look like that, it could look like that, it could look like that. We don't really know anything else about the line except that it crosses at that point. And that's where slope comes in, right? So let's look at our slope. What we know is that as x increases by 1, y increases by 1, right? That's what we learned from having our slope of 1. The change in y is 1, and the change in x is 1. So we can, on the graph, we can just say to ourselves, okay, y is going to change by 1. I'm going to jump up 1 point. X changes by 1, it increases by 1, so I will move on the x-axis 1 point, and there's another spot right there, another coordinate point, right? And we learned that from the slope. All right, so we'll call that 1 and 6. Now, other things also equal 1, right? Our change in y could be 3, and our change in x could be 3. Oops, sorry. Our change in x could be 3. And that would also give us a slope of 1. So let's just try it. Right, let's just pretend that we have a 3 over 3. So I'll increase this by 3, and that would give us 4. And I'll increase this by 3, and that would give us 9. And let's see what that would look like in our graph, right? We'd say we would increase the y by 3, 1, 2, 3. We'd increase the x by 3, 1, 2, 3, and that would give us a point right there. Now the question is that really a different slope? And the answer is no, right? Because if we were going by ones, we can still see 1, 1, we'd have a point right there. If we were counting by ones, we would say 1, 1, and we'd have a point right there. And we see that those are all on the same line, right? So what's important to take away from this is we start off by looking at our y-intercept. That gives us a point to start with, right? That's our y-intercept right there. That was our y-intercept right there. And then from there, we can use the slope to count the rise over the run, or the change in y over the change in x. Okay, let's try another one. Right, let's take a look at another equation. Now this one gives us another dilemma, right? We see, okay, hey, look at that. There is my slope. That's great. But where is the y-intercept? If there's no y-intercept, you can kind of think of this as being plus nothing. And the number we have to represent nothing is 0. So that means, right, my y-intercept is 0. When x is 0, y is 0. And that puts our y-intercept right here. Okay, that's our starting point. All right, we also know our slope is 3. Right? That's our slope right there. So think of our change in y over our change in x, and that's going to equal 3 of some sort. So the easiest way to do this is write 3 over 1. Okay? Erase this a little bit here. So that means that we can just look at our table. Oh, my pen back. Look at our table. And let's change our y by 3. And let's change our x by 1. Right? Plus 3, plus 1. And so our next point is going to be at 1, 3. 1, 1, 2, 3. There it is. That's point 1, comma 3. We can also just count on the graph, right? We can say, all right, the next one, we're going to change y by 3, right? It's going to go up 1, 2, 3. And we're going to change x by 1. And there it is. And that is going to form our line. Okay, I don't have a ruler, so forgive me, that line is not perfect. So you can use the table and the graph in tandem. That means together. Use them both at the same time. Right? We start with our y-intercept to give us our first point, and then we use our slope to find the second point. All right, let's take a look at another one. This is interesting. It looks like there's no slope, but remember, of course, that means that there's a slope of 1, right? A slope of 1. So 1x. And it's also negative, right? So that's interesting. Negative 1 equals 4. Oh, and wait. Now that I'm looking at this, this doesn't look like it's in the right form. It should be y equals something, our slope times x, plus our starting amount. So we've got to do some arranging on this. So this is a difficult one, right? This is something in a different form. I've got y minus x equals 4. I need the y to be by itself on this side. So I'm going to have to do some shuffling around. How am I going to get rid of this x? Well, this is where your algebraic manipulations come in, right? To get rid of that x, that's a minus x, we want to add an x. And remember, of course, we want to keep this equation balanced, so I'm going to add an x to the other side. So what we end up with now is y by itself, right? We got rid of the x, y equals, and then I'm going to write the x first, right? It looks like now my x is positive, x plus 4. Y equals x plus 4. And now we can work with this just like any other. Now that it's in the proper slope-intercept form, we can work with it like anything else, right? Now I'm going to say, remember, our coefficient is 1. Change the color here. Our coefficient is 1. So y equals 1x plus 4. So real quick, let's find our y-intercept, right? This number right here. Y-intercept is 4. Okay? When x is 0, y is 4. Sorry, this is bugging me. This is a little bit ugly. I'm going to rewrite that real quick. I'll put it in yellow. Switch back to my pen here. Y equals 1x plus 4. Okay, so we have our y-intercept, and we have our slope. Slope is 1, so that's real easy. Rise 1, run 1. Change in y is 1, change in x is 1. Right? And when the slope is 1, of course, you know lots of things like, for example, 3 over 3 could also equal 1. So let's just take a bigger jump here. 1, 2, 3, 1, 2, 3. And that puts us on the same line. I could go by one step. I could go by one step, right? But your slope could be 3 over 3, or it could be 4 over 4. Heck, it could be just for fun, could be -2 over -2. That also equals a slope of 1. Watch, I could go down the y-axis, -2, and I could go on the x-axis, -2, and it still puts me on that same line, right? All these coordinate points fall on the same line. That's because of the slope of 1. All right, let's look at one more. Boom, boom, boom. All right, again, this is not in slope-intercept form, so we're going to have to do some manipulations. We're going to have to change it around. So let's try it. I need to get y by itself. So what I need to do is get rid of this. How am I going to get rid of a positive x? Well, I'm going to subtract an x. And remember, I want to do that to both sides. So what I'm left with on the left side is y equals, and what I have left on this side is I could write 2 minus x, but let's write it in slope-intercept form. I'm going to write -x and a +2. All right, so it's that easy to get them into shape. It's that easy to get them into shape. So now we have a slope of -1 and a y-intercept of 2. A slope of -1, right? So just make a little note over here. M equals -1, and b, our slope, equals 2. So that means when x is 0, y is 1. Go over here. Oh, that is not what I wanted to do. It says when x is 0, y is 2. My mistake. When x is 0, y is 2. I need a red. And I can just follow, and what does it mean to have a negative slope? Well, let's see, that means the change in y, right? The change in y over the change in x is going to be -1. So basically we're saying it could be, -1 over -1. Maybe we'll write that a little differently here. Let's say -1 over -1. So my change in x is going to be -1. Gives me -1. This is going to be -1. Excuse me for a quick sec. -1, that would bring me to 1. -1 on the x would bring me to -2. -1 on the y would bring me to 0. So let's kind of graph these out. Okay, -1, our next point will be right here, -1, 1. That's right there. My next point will be -2, 0. So I'm going to go -2 on the x-axis, 0 on the y. And we see these are making a line. And that's a negative line. So that's our negative slope. All right. So these were 4 examples of maybe confusing situations, right? How to find the slope, how to find the y-intercept, and how to change an equation around so it fits into slope-intercept form.